So hi students, let's do this question, okay? Find the Z parameter of the network. So this is the given circuit, and here you can see that this current, in some question, right, here in this question they have marked V1 I1 and V2 I2, okay, but that may not be always the case. In some cases, sometimes they won't mark V1 I1 V2 I2. So in that case, you need to understand that you should mark at first port, you should mark V1 over here, and also remember the direction of I1 is always into the network, and also you should remember to mark V2 where this is the positive polarity, this is a negative polarity, and also don't forget to mark I2, which is the current into the network, okay, in this direction. So this is always constant. Whichever parameter they give you, these four values must be seen for any network, whatever the network they ask you, okay, and the direction of the current should always go into the network. For both the current, it goes into the network, okay. So before applying the problem, and here also they have said also check if the network is symmetry or reciprocal, okay. So I'm just going to show you how this problem is being done, okay. There is no any clear-cut rule. So here this is nothing but simple mesh analysis. This is all nothing but pure mesh and node analysis. There's nothing else over here, okay. So what I'm going to do is that I'm going to first let me draw another version of the circuit. This circuit is written in real time. So you see here you have a 1 ohm, you have a capacitor of 2 Faraday, and then you have 1 ohm over here, you have 2 ohms over here, and you have 1 Henry inductor over here. So what I'm going to do is that I'm going to apply the Laplace transform to this network, or I'm going to draw the transformed network, okay. So by applying transform network, then how this circuit will look like is, I will draw it like this. So we have 1 over here, and this is the transform is 1 by CS, right? And here C is 2, so therefore we have 1 by 2S. So this is 1 by 2S. The impedance of this capacitor is 1 by 2S, 1 by 2S, and the resistor is again 1 itself, and the resistor over here, the impedance is 2 ohms itself, and here we know it's the impedance is for inductor, the impedance is LS, right? So here the value of L is equal to 1, so we have the inductor as 1S, or simply S, okay. That's it. So this is your network, okay, and don't forget this is V1 and this is I1 and this is V2 and this is I2, okay, don't forget that. So that's it. And alright, and now the first thing I'm going to do is that I'm going to see if they ask any parameter equations, okay. This is very important. Whichever parameter they ask you for, if they ask you to find, always write that parameter equation, always write it. It's very good. It's very, so that you will be able to remember what are the, so you will always be able to remember what are the parameters you are trying to find, okay. So here they asked Z parameter, so I'm going to write the Z parameter equation. So which is, the equation is Z parameter equation is V1 is equal to Z11 I1 plus Z12 I2, okay, and V2 is equal to Z21 I1 plus Z22 I2, okay. So always don't forget to write your Z parameter or your parameter equation. Whichever parameter you're asking, you need to write this equation. So advantage of that is that you will be able to know what you're trying to find, okay. So which means you need to find the equation. In this case, you need to find the equation where you see only V1, I1 and I2 in that equation. Also, you need to make another equation in which, in that equation, only V2, I1 and I2 should be there. Okay, so like that you need to find the equation, okay. So here I am going to apply mesh analysis. Now before applying mesh analysis, I need you, this is not like your ordinary mesh. In a normal mesh currents, there is no restriction in how to apply the direction of a mesh current. So just for your easiness, what we did is that we assumed that all the mesh currents are flowing in the clockwise direction. That's how I taught you in the previous video, right? In the previous video, when we are doing mesh analysis, we assumed that the direction of the current is the mesh current is the same, all of them in the clockwise direction. But here we are not going to do that because we have already assumed that there is a current I2 flowing into the network and I1 flowing in the network. So if I'm going to assume a mesh current, I'm going to assume a mesh current that will actually respect these parameter current also. So which means that if this is I1, okay, if already I have marked I1, then I can say that my mesh current over here is called as I1. See, and why I drawn in this direction? Because that is the direction of my I1 direction. So my calculation will become much more easier. See, so basically I have made my mesh current equal to my parameter current. That is why I have applied this equation. In the same way, since I have already marked the current I2, and if you look over here, all the I2, the direction of I2 is in this direction, which means I'm going to say that this mesh, I'm going to call it as mesh 2, and the current is I2, and the direction of I2 is anti-clockwise. Why it is anti-clockwise? Because I have already marked I2 over here. So by marking the mesh current I2 in anti-clockwise, I have said that the mesh current and the parameter current will become equal to each other. Okay. That is why I marked it. That is the only difference over here. That is the only, unusual thing that you need to do, or the difference you need to do. Now, there's one more mesh over here. What you can do is you can apply it anyway. So what I'm going to do, apply it as in clockwise itself. And since I have already the name I1 and I2 has already been taken up, so I will use the name I3 over here. Okay, that's it. So now I just need to express these equations and then try to express those equations in terms of these parameter equations, and that's it. I have found the answer. So let's see equation over here. What is the equation? According to this, I1 into, we have 1 plus 1 by 2s, so 1 plus 1 by 2s, okay, and then the only other current that's touching this one is I3, and I3 is in the opposite direction of I1, so we say minus I3 into 1 by 2s is equal to V1. So this is the equation for mesh 1. Okay, now what about the equation for mesh 3? Let me write the equation for mesh 3. So for this mesh, you can say that over here you can see that that I1 is flowing in the opposite direction of I3, but I2 is flowing in the same direction as I3. So therefore I1 is negative and I2 is positive, which means in the mesh 3 equation, I1 is negative and I3 and I2 are positive. So I say that minus I1 into, and I1 is touching only this element, so it is 1 by 2s plus I3, and I3 is touching these two elements, which is 1 plus 1 by 2s, okay, and I2 plus I2. Why it is plus I2 is because I2 is also flowing the same direction as I3. That's why, see, both of them are going from top to bottom. That is why I2 is also positive, and I2 into is touching only this element, so I2 into 1 is equal to, there is no voltage source anywhere over here, so it's equal to 0. So this is mesh 3, or the middle mesh equation. Now the mesh equation for this is, as you can see here both there is only I3 and I2 over here, right? And I3 is touching only this element, and also I3 is positive because I3 and I2, both of them are going downwards, same direction. So therefore it is I3 is also positive. So I3 into 1 plus I2 into, and what about I2? I2 is touching these three elements, that is S, 2 and 3. So S plus 2 plus 1, which is S plus 3, is equal to, this is a voltage source, so it's V2. Okay, that's it. So these are the three mesh equations. So like I said, you are trying to find the value of you are trying to express V1 in terms of I1 and I2. I have found the value of V1, but it's in terms of I1 and I3. Okay, and also if you look over here, I have expressed V2. I need to find the equation for V2 in terms of I1 and I2, but I have found the equation for V2, but it's in terms of I3 and I2. So in both this case, as you can see here, in both the case, the one thing that I don't want is I3, and I want over here I2, and the one thing that I don't want is I3, but I want over here is I1. That is what I need to do. Okay, so you see, from here onwards, everyone has their own style. Okay, so you don't have to follow my own style. Anyway, I'll just do how for this problem, I'll just show you how to do it. Then in the coming problems, I want you all to do it by yourself. Okay, now that is one way of doing. The other way of doing is that, like I said before, if you want to find the value of Z11, okay, what is the equation for Z11? Z11 is equal to V1 by I1 when I2 is equal to 0. So which means you just need to find the value of V1 by I1 in this parameters when I2 is equal to 0. So you need to put I2 is equal to 0 in your equation. In that case, you can find the value of Z11. You see, like that you can find the value of Z11, Z12, Z21 and Z22. Okay, but that is also one way of doing. That's another way of doing. Okay, so this time I'm going to apply it by simply expressing those equations in this parameters. So that will save more time. So let's do this equation. So here, like I said before, I don't want this I3. So what I'll do is, what do you want me to do? Okay, I'll express this equation mesh 2 in terms of, I'll express I3 in terms of I1 and I2. Okay, I'll express I3 in terms of I1 and I2. In that case, the equation for I3 becomes I3 into 1 plus 1 by 2s is equal to, so if this thing comes over here, it becomes plus I1 by 2s. Okay, and over here it is plus I2, it becomes minus I2. Alright, it becomes minus I2. Okay, now if I want, I can just simplify this equation, and so this will become multiplying the entire equation with 1 by 2s. I will get I3 into 2s plus 1 is equal to I1 minus I2 by 2s, or I2 into 1 by 2s. Okay, that's it. So I found this equation. Okay, or in other words, I can say that I3 is equal to I1 into 1 by 2s plus 1 minus I2 into, you have, or if you're multiplying entire this equation, then 2s will be over here in the numerator, right? It won't be at the denominator, it will be at the numerator. Okay, I made a mistake over here. So therefore this becomes 2s by 2s plus 1. Okay, that's it. This is how the equation will be. Okay, if you're multiplying the entire equation with 2s, 1 into 2s is 2s, 1 by 2s into 2s is 1. Here also 1 by 2s into 2s is 1, and here 1 into 2s is 2s. So 2s will come as the numerator, not the denominator. Okay, so this is the equation for I3. So what I will do is, I will substitute this equation over here and over here in order to express V1 in terms of I1 and I2, and express V2 in terms of I1 and I2. So first I'll apply it over here. Okay, over here. So here we know that V1 is equal to, let me write the equation again. V1 is equal to I1 into 1 plus 1 by 2s minus I3 into 1 by 2s, right? That is the equation. That is the equation, right? So now what I will do is that I will apply the value of I3, that is this equation over here. So this will become I1 into 1 plus 1 by 2s minus I1, okay, I1 into 1 by 2s plus 1 minus I2 into 2s by 2s plus 1, okay, into 1 by 2s. So this is basically I3, okay. I expressed I3 in terms of this equation. Now I'll multiply 1 by 2s in both the parameters, so I will get I1 into 1 plus 1 by 2s minus I1 into 1 by 2s plus 1 into 2s plus, because minus of minus is plus, so plus, and this into 2s is 2s and 2s will cancel, so you will have I2 into 1 by 2s plus 1, okay. You have 1 by 2s plus 1. Now I need to combine these two values, so therefore you have I1 into 1 plus 1 by 2s minus 1 by 2s into 2s plus 1 plus I2 into 1 by 2s plus 1, okay. Or this is also equal to I1 into, let's see, if you take the reciprocal, this will become 2s into 2s plus 1 plus, and the reciprocal over here, here the LCM is 2s into 2s plus 1, so the numerator over here is 2s plus 1 minus, and here the numerator, here the reciprocal is already same, 2s into 2s plus 1, so therefore the numerator is exactly the same, so by 2s into 2s plus 1, okay, plus I2 into 1 by 2s plus 1, so therefore 1 and minus 1 will cancel each other, so and also you can take 2s common, right? You can take 2s common also outside, so therefore you will have I1 into, taking 2s common, so this will become, let me see, if you take 2s common, right, so this will become 2s into 2s plus 1 by 2s into 2s plus 1, okay, plus I2 into 1 by 2s plus 1. So 2s and 2s will cancel each other, so therefore we have V1 is equal to I1 into 2s plus 2 by 2s plus 1 plus I2 into 1 by 2s plus 1, okay. We already know that V1 is equal to Z11 I1 plus Z12 I2, so which means from here itself we can say, we can simply write the value of Z11 and Z12, right? This is Z11 and this is Z12, okay. In the same way, now I'm going to express the equation in terms of V2. So V2, the equation for V2 is, let me see what's the equation for V2. For V2, the equation is I3 plus I2 into S plus 3. I2 into S plus 3, okay. And we already know the equation for I3, right? We have already found the equation for I3. That is this equation over here. So substitute the equation over here. We have I1 into 1 by 2s plus 1, okay, minus I2 into 2s by 2s plus 1, 2s by 2s plus 1 plus I2 into s plus 3, okay, I2 into s plus 3. So this is nothing but I1 into 1 by 2s plus 1 minus I2 into, now I need to combine all these values, so this will become 2s by 2s plus 1 plus s plus 3, or in other words, this is I1 into 1 by 2s plus 1 minus I2 into, this is 2s plus, this is 2s square plus s plus 6s plus 3 by 2s plus 1. Okay, or in this other words, this is I1 into 1 by 2s plus 1 minus I2 into, this is oh, I forgot, this is minus 2s, right? This is minus I2 and this is plus. So if minus means, if we will just put plus over here and put minus over here, plus over here and minus over here, okay, plus over here. So which means you will have, let's see, that's I forgot to see, because this is minus actually, right? Minus I2. So this term is actually minus. This term is additive, this is subtractive, negative number. So it becomes minus 2s, okay? So here we can say 6 plus 1, 6s plus s is 7s, 7s minus 2s is 5s. And so this becomes 2s square plus 5s plus 3 by 2s plus 1, okay? This is V2. So therefore we know that V2 is equal to Z21 I1 plus Z22 I2. So which means this is Z21 and this is Z22. Okay, that's what it means. Or in other words, okay, in other words, we can say that we can write the answer as in this form, that is Z11, Z12, Z21, Z22 is equal to, what is Z11? The equation for Z11, you see, we all know, right? V1 is equal to I1 Z11 plus I2 Z12. So this is Z11, this is Z12, that is 2s plus 2 by 2s plus 1, 2s plus 2 by 2s plus 1, and the equation for Z12 is 1 by 2s plus 1, 1 by 2s plus 1. The equation of Z21 is, see, because we know that V2 is equal to Z21 I1 plus Z22 I2. So which means Z21 is 1 by 2s plus 1, and the equation for Z22 is 2s square plus 5s plus 3 by 2s plus 1. Okay, this is the answer. Okay, now to check if the network is reciprocal and symmetry. Okay, so here you can see that, let me see, here you can see that Z12 is equal to Z21. See here, comma, Z12 is equal to Z21, and this, both of them are equal to 1 by 2s plus 1. Therefore the network is reciprocal. Okay, therefore the network is reciprocal. And for the symmetry, Z11 should be equal to Z22, but here Z11 is not equal to Z22. So since Z11 is not equal to Z22, comma, the network is not symmetry. Okay, so this is your answer. So that is the use of the matrix form. That is, if you can write the final answer using in the matrix format. Okay, this is Z11, this is Z12, this is Z21, and this is Z22. Okay, so this is how we do the problem. See, so here basically what I did is that I simply applied mesh analysis and I tried to express my circuit equation in terms of my parameter equation, and then I finally I found the values by simply comparing the equations. Okay, and this is how we check for the reciprocity and symmetrical. Okay.